All right, 10 ways the ocean kills you. Let's go. Number 10. High pressure nervous syndrome. You do not feel it start. No sting, no sound, no flash. The pressure itself reaches into your skull and begins to dismantle the way you think. At midnight zone depths, the weight of the ocean compresses brain tissue and scrambles the chemicals that carry signals between neurons. Scientists call it high pressure nervous syndrome. Divers who survived early deep saturation experiments described it as losing your mind one layer at a time. First come the tremors. Your hands shake and you cannot hold a tool. Then anxiety floods in for no reason. Your vision warps, straight lines bend, gauges become unreadable. At 1,000 meters, even helium-oxygen breathing mixes cannot fully prevent the syndrome. In dry chamber tests simulating 700 meters, trained Navy divers became completely unable to function. They could not perform basic arithmetic. They could not follow single-step instructions. Their brains simply stopped cooperating. Now picture a crude submersible that suffers a pressure breach at depth. The cabin is no longer at surface pressure. The occupants begin breathing air compressed to midnight zone levels. HPNS, nitrogen narcosis, and oxygen toxicity hit the brain simultaneously from 3 directions. Thinking collapses before fear arrives. Motor control vanishes before you can reach an emergency lever. The brain shuts down in a sequence so fast there is no pain and no awareness that anything went wrong. You were a person. Then you were not. Cabin pressure is held by triple redundant seals and continuous monitoring. Those layers work when the breach is slow. A sudden crack at depth equalizes pressure in milliseconds, and no seal, no alarm, and no human reflex can outrun it. Number 9. Venomous stingers. Something brushes your hull and leaves a smear of slime across the viewport. You did not see what it was. Down here you rarely do. Siphonophores drift through the midnight zone as living curtains that can stretch 45 meters end to end. They are not one animal. They are a colony of specialized bodies fused into a single predatory machine. Along those curtains hang tentacles loaded with millions of nematocysts, each one a pressurized harpoon that fires on contact and injects venom roughly 3/4 as potent as a cobra's. A diver or a breached suit that brushes a siphonophore does not get a warning. The sting hits across meters of skin at once. Pain is immediate, severe, and disorienting. Breathing muscles can seize, heart rhythms can stutter. At depth, where medical help is hours away, a full-body sting can cascade into cardiac arrest before anyone on the surface even knows something went wrong. Giant phantom jellyfish patrol the same water. Their bells span a meter, and their trailing arms reach 10 meters below. The Atolla jellyfish sits at 3,000 meters and uses a bioluminescent alarm display to summon larger predators when threatened, turning a close encounter into a feeding event around your craft. Chimeras, ancient relatives of sharks, carry venomous dorsal spines that inject toxin on contact. They cruise the midnight zone looking for shellfish and will not dodge a slow-moving submersible. A spine through a cable sheath or sensor housing introduces venom and salt water into systems that cannot tolerate either. Detached tentacles keep stinging for days after the animal is gone. ROV operators have pulled cloudy threads off camera housings and watched seals degrade underneath. The midnight zone is threaded with invisible chemistry that does not care whether you are alive or made of steel. Number 8. Giant squid attack. A sonar shadow swells on the screen, and then something alive wraps around the hull. Down here, the ocean builds predators on a scale that makes human engineering feel like tinfoil. Giant squid can stretch beyond 13 meters. Colossal squid carry rotating hooks in their tentacle clubs that lock into flesh and do not let go. Both species hunt in the midnight zone, and both have been found in the stomachs of sperm whales that dive here to fight them. Humboldt squid have already attacked submersibles. In the Bering Sea, a swarm sprayed ink across a Greenpeace craft, latched onto the hull, and damaged a thruster so badly the crew aborted the mission. That was a smaller species in shallower water. At 1,000 meters, a colossal squid that mistakes your craft for a rival or prey can foul thrusters in seconds. Tentacle clubs lined with hundreds of serrated suckers grip metal the way they grip whale skin. Cables snap, sensor housings crack, a viewport seal that was never designed for a lateral wrench can pop under the added load. At depth, that pop is not a slow leak. The ocean floods in at pressure, and the cabin implodes before anyone can reach a valve. ROV operators have watched large cephalopods wrap arms around camera booms and bend steel mounting brackets like wire. The Midnight Zone built these animals to seize and hold. Your submersible was not built to be seized. Number 7. Oxygen dead zone. You feel the cabin breath change before you hear anything. The meter drops, the digital readout stutters, and the air tastes oddly thin. Outside, a pocket of water with no dissolved oxygen has been pushed in by currents or a landslide. That water looks like water. It kills like a thief in the dark. The mechanics are blunt. Water with near zero dissolved oxygen replaces the normal sea. If that water floods a damaged hatch or an external inlet, it carries nothing for you to breathe. Even in a sealed cabin, the flood can carry gases that displace oxygen. This is not a long struggle. Your brain needs oxygen right now. Within seconds, your thinking blurs. Within a minute, you are likely unconscious. Carbon dioxide makes it worse. When CO2 rises, it triggers panic breathing and a desperate gasp. At depth, that gasp can suck in contaminated water or inert gas and end everything. Life support relies on multiple oxygen sensors, alarms, and scrubbers. Redundant supply tanks and fail-safe valves back them up. Those systems assume time to react. A sudden massive inflow of anoxic water or a gas pocket can overwhelm scrubbers and drown alarms in false readings. When the meters go quiet, you do not have long. Number 6. Methane blowout. You are drifting a few meters above the seafloor when the mud under you burps. At first it looks like a shimmer, then a column of bubbles races skyward and the water under your craft goes suddenly light. Those bubbles come from methane trapped as ice-like material in the sediment. A disturbance can melt that ice and release huge amounts of gas fast. The killing starts with physics. The rising bubble curtain lowers the density of the surrounding water. That drop in density removes buoyant lift under a small submersible or an ROV. Controls go soft. A vehicle can fall or tumble into the seafloor with no time to correct. At the same time, the plume can carry gas into a breached cabin or a damaged suit and push out oxygen. You do not need poison for death to be instant. A single breath of gas that does not support life makes you pass out in seconds. Dense pockets of carbon dioxide can collect alongside and behave like a heavy, invisible cloud that overwhelms sensors and scrubbing systems. Gas monitors and alarms exist. They cannot fix a sudden, massive release in time. Number 5. Sperm whale strike. Picture a shape the size of a city bus surging out of the black. Inside your tiny metal sphere, you have about half a second to understand what is happening. A sperm whale is a living mass of muscle and blubber weighing 40 to 50 tons. It moves fast when it hunts. A collision with your craft is not a gentle bump. It is instant structural failure. Momentum equals mass times speed. A whale has enormous mass. Even a slow crossing transfers huge momentum in a heartbeat. Your hull experiences a sudden load that it was not designed to take from that direction. Welds snap. Viewports fracture. A small breach at depth becomes catastrophic. Flooding is immediate, and the pressure outside turns a leak into a rupture. Systems fail in a blink. Nobody runs checks or cycles emergency protocols because nobody has time. Whales do not aim to kill humans. They hunt squid and navigate by sound. But when a huge animal and a small vessel meet, physics decides the outcome. Pilots have seen ROVs knocked aside by large animals, and animals strike nets and lines without warning. The Midnight Zone is full of life, the size of which makes our hardware fragile. Number 4. Turbidity current. One moment the slope below is quiet sediment. The next, it turns into a river of mud, and the seafloor moves like a storm. Sediment and water collapse, and a dense curtain surges past. It is not slow. The current can travel faster than the fastest ship and carry boulders and sand in a wall of force. The moving mass hits with the force of many tons. It scours metal and glass. It buries cameras, arms, and tethers in a blanket of silt. Visibility drops to zero. Thrusters clog and control is lost. A small vehicle that is stable in calm water becomes a log in a flood. The flow can topple or crush a submersible and then bury it alive under meters of sediment. Triggers are simple. An earthquake, a slope that has been overloaded, or even a big storm above can set off the slide. Once it starts, the momentum feeds itself and nothing on the seafloor stops it. ROV pilots watch their video screens go from clear to opaque in a single pass. Recovery is near impossible because buried systems are smashed and instruments fail. The midnight zone can bury you with the patience of geology. Number 3. Seafloor volcanic eruption. The seafloor splits and light comes from below. That light is not bioluminescence. It is molten rock. The midnight zone sits on some of the most tectonically active terrain on the planet. Mid-ocean ridges span 65,000 kilometers, and they pull apart constantly. When magma punches through the crust at depth, forget the gentle lava flow you see on television. Superheated rock at 1200 degrees Celsius meets near freezing seawater, and the contact creates phreato-magmatic explosions. Shockwaves ripple outward through water that transmits force far more efficiently than air. A submersible within range does not rock gently, it is slammed. The 2022 Hunga Tonga eruption sent volcanic debris flows racing across the seafloor at 122 kilometers per hour. Those flows buried submarine cables under meters of rock and ash. A small craft in that path would be shredded and entombed. Beyond the blast, the eruption vents toxic gas. Sulfur dioxide, carbon dioxide, and hydrogen fluoride pour into the water column. In an enclosed cabin, a single intake of contaminated water through a cooling line or a cracked seal floods the air with poison. Scrubbers cannot handle volcanic concentrations. Mission planners route dives away from known volcanic sites, but the deep seafloor hides fissures that have not erupted in centuries. When one wakes, there is no siren. Heat, force, and toxic gas arrive together faster than a human can process a single thought. Number 2. Hydrothermal vents. You hover above a black chimney on the seafloor and a river of superheated fluid smacks the cold, dark water. The plume is not warm. It is a chemical inferno. Vent fluid can be hundreds of degrees Celsius at the source. At depth, that water stays liquid under immense pressure. If that plume touches exposed skin or a damaged suit, the heat cooks tissue in seconds. Flesh does not slowly burn, it denatures and sloughs away before you can react. The heat is only part of the danger. Vent fluid carries dissolved acids and heavy metals. It tastes of sulfur and metal, and it will shred mucous membranes. The chemicals attack eyes and lungs. Inhaling even a small breath of a hydrogen-rich plume can black out your breathing control. Organisms around vents survive because bacteria consume those chemicals and build food webs from them. They are adapted in ways we are not. A breach near a vent can release scalding steam pockets and violent currents that slam a small submersible against rock. Seals meant to hold a leak can fail in a puff of hot, toxic fluid. In minutes, your environment goes from controlled to lethal, and the chemistry gets worse. Beyond the heat, the vent fluid is a cocktail of acids, heavy metals, and dissolved gases. Hydrogen sulfide smells like rotten eggs on the surface, but at the vent, it acts like a chemical choke. It binds to enzymes that cells use to breathe and shuts them down. A single breath in a high concentration, and your brain and heart lose power. Heavy metals, such as mercury and arsenic, come dissolved in the plume and attack nerves and organs. At depth, the fluid can be hundreds of degrees Celsius and stay liquid because pressure prevents boiling. That means a vessel or a human who intersects the plume meets scalding hot and chemically corrosive water at once. Robotic pilots report seals and sensors pitted in minutes, and cameras clouded by dissolved particles. Animals that live there tolerate it because bacteria convert those chemicals into energy and build a local food web. We do not. Submersibles carry insulation, redundant seals, and chemical scrubbers. But a sudden burst of vent fluid can overwhelm every layer faster than a hand can reach a switch. The vent is an oasis for life and a furnace for anything human-made. It is proof that extreme life and instant death can share the same stone. Number 1. Crushing pressure. You are inside a small metal sphere as the world above goes silent and dark. At 1,000 meters down, the water presses on you with 100 to 400 atmospheres of force. That pressure is not like wind. It comes from every direction at once. Every 10 meters adds 1 atmosphere of weight, which means the deeper you go, the more the ocean squeezes. Your lungs and any air pockets in your suit will compress. Soft tissues are pushed together until organs fail. Deep-sea animals survive by having no air spaces and by soft, flexible bodies. They evolved proteins and membranes tuned to handle compression. Humans did not. So we cheat with thick titanium spheres, careful welding, and multiple backups. They test designs until they will not fail under extreme loads. Yet the truth is brutal. One tiny, unseen crack focuses force and the hull can give in a single instant. No time to scream. No time to reach for a lever. Any trapped gas pockets in the body move violently under compression and can tear blood vessels. When pressure wins, you do not feel a slow decline. You are gone. Implosion. The crack that matters can be smaller than a fingernail. Steel fatigues. Bolts loosen. A tiny scratch becomes a focus point where force concentrates and the hull fails. When that happens, the outside rushes inward faster than any human reaction. The trapped air collapses, pressure equalizes in an instant, and the energy becomes a shock that destroys everything inside. No slow pain. One brutal moment that ends the story. The defense is shape, material, and margin. Spheres spread load evenly. Thick titanium and composite layers add safety. Every weld is inspected. Every pressure test simulates depths for hours. Redundant systems and emergency seals give crews time to respond to many failures. Still, the deeper you go, the smaller the margin becomes. Even the best design cannot forgive hidden corrosion or a bad manufacturing run. Biology gives a second lesson. Deep animals do not gamble with trapped air. Many are gelatinous and flexible. Their proteins and cell membranes work under compression in a way ours do not. Microbes and fish have enzymes that keep folding under pressure. Those same traits make them fragile at the surface, where their chemistry is wrong. Humans are the opposite. Our lungs, sinuses, and cavities are fatal liabilities at depth. Crushing pressure is the one thing that never leaves. Every other danger on this list assumes you survive the squeeze. This one does not. It is the midnight zone's first rule and its last word.